and so that we can address them at the end of the session. So having said that, let's kick off the session with no delay. Okay, so how to be interactive during the session and take questions at the end of the session, right? So I said we'll be having a Q&A session at the end, but still I want you to be more interactive. How is through the chat box, okay? So we have a chat box in the Zoom meeting. So please do use chat box. So since there is a huge participant, we cannot have a one-to-one introduction. So hence I request you all to update your name, phone number, and which part of the world you are located, and also some reason for attending this session. Maybe you can give a quick intro in the chat session so that I can go through it later. So please feel free to type in the chat box. Maybe I'll give a one second for you to update your information in the chat box. Hi, Haren, Arvind. This chat box is accessible to you all. Hope you can type the comments, right? At least your name and phone number will do. So that this is the medium for me to understand that you are with me. So you can acknowledge me through this chat box. Hi, Karthik. Yeah. Hi, Alex. Yeah. Yeah. Good morning. Very good morning to you all. Oh, great. Hi, Bala. Yeah. Yeah. Take a minute or take a few seconds to update your information in the chat box. So this flow of message will give me a confidence, and so this is the communication. You are acknowledging my speech, right? So you can acknowledge me through this chat window. Good. Thank you. Thanks, Kritika. Yeah. Okay. Anybody who joined late can also give your details here. Like this is just an intro from your end. You can give your name, your number, and which part of the world you located, and maybe you can also give a small reason why are you here. What is your expectation? Not mandatory, but optional. Yeah. Okay. So let this go. What I'm going to do is I'm going to move on to the slide. Okay. So let's set up the context here for this today's session. So this workshop is intended for not only the system administrators, but also for the aspiring system administrators. Okay. So I strongly believe that in this session, we will definitely have a mixture of audience. So few audience maybe with good knowledge in Linux, a few maybe with moderate, and a few maybe with low or sometimes no prior knowledge about this topic at all, right? So hence, I try to design this workshop in such a way that even a newbie with no experience can understand. Okay, so I try to avoid a lot of jargon words. So I try to keep a more logical way of understanding. So in the next 40 to 45 minutes, so we will be discussing what is performance and what is performance bottleneck, and when the performance bottleneck can happen, and if it happens, so then what are the built-in tools available. So what are the built-in tools available to identify the bottleneck, and what is the need for dedicated performance tools, and their contribution in performing the in performance tuning. And finally, we will also discuss the best practices, do's and don'ts in performance tuning. And last but not least, we will have the Q&A session. All right. And there is also an announcement slide in between. So which speaks about the various courses that are offered by OSC Labs, and you also have a surprise offer of the day, and so on. So please keep watching for that space as well. So as I said before, you can use the chat window during the session to acknowledge me, So please be more interactive throughout the session. Okay. Yeah, we can see a lot of users are still joining. This is a good sign. Okay. Yeah. So people who just joined, you are not too much late. So we are just requesting everybody to give your details in the chat window, and we are about to kick off now. Okay. We just set the agenda, and I'm just going to slide number 3. Okay. Okay. So don't panic seeing these bike pictures. So we are into Linux performance workshop and not into any automobile workshop. So why these pictures is to understand what is performance in a layman term. Here we have 3 different two-wheelers, right? So just by seeing them, one can easily say that which bike can perform up to what level, correct? So here the performance metrics could be speed, mileage, etc. Right? So, but if suppose this moped kind of bike and this super bike, right? This super bike are performing equally, then obviously there is a performance issue with this super bike, correct? So what it means is this super bike has more potential, but it performs less. So this similar incident in Linux operating system is what we call as performance bottleneck. Okay, so as similar to this different variants of bike. Okay, anybody who's not speaking, please go on mute. Okay, so we are speaking about performance, and as similar to these different variants of bike, the servers that are placed in data centers can be also classified as entry level, mid-range, and high-end servers. Okay, so instead of engine CC in bike, here for servers, we use CPU clock speed, gigahertz, cores, etc. As a benchmark, right? So, and top of this, there is something called RISC consist architecture, okay, which is good to know when it comes to hardware. So it is important to know on which type of servers we are tuning and what result we are expecting. Okay, so what I'm meaning is we cannot tune this moped. We cannot tune this moped to perform like a super bike. Correct? Hope you got the point, right? So we must know what hardware we are working and what the capability of the hardware. Okay, so otherwise we will be keep on tuning this bike or this moped for the lifetime, but we will never reach this goal at all. Okay, so that's the reason why we should know we should have a good knowledge about the hardware which we are working on. Okay, and a note here is the picture whatever you see on this server may not be in the real time as well. What I mean is, so nowadays when the technology is upgraded, right? So these server sizes are also decreased. So you will see a similar kind of rack servers even for high-end servers. So just for a logical understanding about the servers, I just posted this picture. Otherwise, it doesn't need to be the same as what you see in the screen. Okay, so I think you got what is a different type of hardware sections we have in the servers. So 3 different servers. Yeah, I'm moving to the slide number 5. Okay. Yeah. So this is a very important slide because all the rest of the slides depends on how you understand this slide. Okay. And so this is very basic read operation. Okay. In this slide, we are going to learn. Let me try to string this. How can I move this? Okay. Okay, I'm trying to hide this. I don't know how to do that. Anyway, not a problem. So yeah, so in this slide, we are trying to understand how a basic read operation in Linux is handled. Okay. So here, see the point number 1. So a system admin or a user here, he fires a cat file. Okay, he fires a command. The cat is the command and some file name. He is giving some file name. And from where he fires this command, probably from a shell, right? From his terminal and a shell, he is firing this command. And where the command is executed, it is executed in this Linux server, correct? And this Linux OS do have lot of device drivers, correct? Linux OS will have lot of device drivers and a kernel. So if you can see my mouse pointer, we have a kernel. And this orange boxes means that all the operations are happening within this Linux server. Okay, so don't think it's happening somewhere else. So all these operations are happening within the Linux server, and this is the Linux server. On this terminal, a user is firing a command, and that command, okay, and that command is handled by this kernel. Okay, so kernel is nothing but is a part of operating system, and it is also called as the heart of the operating system, right? Okay. So this Linux OS do have kernel and a lot of device drivers. So any command that is fired in this Linux will start a process. See, the point number 2 is a process. So any command you fire, any application you start, in turn, Linux will create a process, and this process will have a unique process ID. The PID stands for process ID. Okay, this is an identifier for a process. So that will be unique number. Okay. Okay, so now what is the purpose of this kernel? This kernel is the interface between the user application and the hardware. Okay, whatever you see after this kernel is a hardware. Okay, I'll explain each and every terms shortly. But for now, whatever you see up to kernel is on the operating system, and after the kernel is on hardware part, right? So this kernel is acting as the interface between the hardware and the user application. Okay, and the kernel also performs the process management. Okay, all the process management. So now what the kernel will do is kernel will watch for this process table. Okay, so here the user have fired only one command, so one process is created. Similarly, if there is lot of commands from lot of different users is fired, you can see a process table is created and lot of process will be appended. Process IDs will be appended. Okay, and all this process are watched by the kernel. Okay, so what the kernel will watch is what when the process in a ready state, So these 4 state, or in other words, this process can be in any of these 4 states. Okay, process can be in any of the 4 states. So kernel will look for the process which is in ready state. Okay, which is in ready state, and this will allocate the CPU clock tick for that particular process. Okay, so why CPU clock tick is required is any process to be executed, we need a CPU clock tick. Okay, the computer engineers may can refresh this from their courses, right? So this CPU clock tick is very, very important for any process to get executed. Okay, so this kernel is the intermediate layer which watch the process table, and it picks the process which is in ready state, and it allocates the CPU clock tick. Okay, so this process, now this process is allocated with the CPU, and what is this process about? This process is to read some file, right? Read some file which is involving some IO functions, So CPU interprets this process and understand that this need a IO call to read some file in the disk. Okay, read some file in the disk. So what it does is this CPU cycle, this interprets, and it is sending it is creating a IO function. So this is the IO system call. We can call it as a system call. We can call it as a thread. When it goes internally, these are all is a thread actually. Okay, or in other words, for a better understanding, you can also understand them as a process, but as a child process. This is the parent process and this is a child process, because this parent process has invoked this child process. Okay, so and what is the purpose of this child process? They want to read some file, right? So this read operation is going to memory. It's searching in the memory for this file. Okay, why memory? The file will be first searched in the memory. Only if it is not found, the disk is searched. Okay, so this is how the operating system is designed. Okay, so that's why you may notice that very first time if you open a file, it may take time, but subsequent attempt, right, it will be very faster. Okay, you might have noticed when you open a file in the Linux system. So now this system IO call, right? After invoking this system IO call, what the kernel will do is it will put this process into sleeping mode. Why? Because it doesn't want this process to occupy the CPU until it completes the read operation, right? There will be a lot of other process waiting in the process table. Okay, they also want to have the CPU clock tick to get executed. Okay, so that's the reason why it immediately after sending the IO, it will put this process into the sleeping mode or sleeping state. Okay, now if suppose the file is found in the memory itself, okay, this read IO is searching the file in the memory. If suppose that file is found in this memory, it will be displayed in the terminal. It will be displayed in the terminal. If suppose if the process, it will set in the it will put the file in the memory, and you can see the file in the in your terminal, and the particular process will be vanished from the process table because it has completed the task. But what if the file is not in memory? What is the file is not in memory? So this will invoke the process again to the ready state, and it will wait for another clock tick. So all process will happen again, and but in the next iterative, right? So it will search in the disk, not in the memory. In the very next time, it will search in the disk, and it will put the file into the memory, and then it can be displayed by the it can be seen in the terminal. Okay, so now the user can read the file content in his terminal. Okay, now the process is completed and it's no more in the process table. Okay, so interesting, right? So how the workflow is working is very interesting, right? So now let's also see when this process will be in the other two states. So we know how when the process will be in ready state, what is running state, and what is sleeping state. So there are other two states where the process can be in, right? Suppose in the same scenario, okay, imagine like system admin have fired this command, and when the process is in sleeping state, okay, this sleeping state it remains for a long time, and the system admin decide to cancel this read operation. Okay, decide to cancel this read operation by sending some control C or kill command, right? Basically how we will kill the process, kill space PID, right? So when he is trying to fire this kill command, so what it will do, it will stop the process. Okay, so what he is trying here is giving kill space PID. Okay, so what this will do internally, this will kill all the child process, and then it will also kill the parent process. Okay, and this process will be put to the stop state. Very what do we call it? We call it as a graceful shutdown, right? Very clean way of stopping the services or a process. All good. And what is this? The last one, the zombie. In the same situation, in the same scenario, if the system admin, instead of firing this kill PID, if he attempted to kill with the -9 signal, okay, if he attempted to send a -9 signal, or this is also called as forceful signal, right? So if you send this forceful kill signal to this parent process, then what will happen is this child process may not get stopped properly. Okay, this is a forceful kill command which will kill the parent process ID and left this child process orphan. Okay, so these kind of orphan process are called zombie process. Okay, these kind of process are called zombie process. We will discuss about this zombie process shortly, but for now, just understand entire workflow. Okay, so that was too much in one slide, right? So but I believe you all are with me, right? So I think whatever I explained is clear. Can I get a small confirmation? Can you type clear or CC in the chat box so that I can understand?
Saravanan, can you hear me?
Yeah, yes.
Yeah, Murli here. Thanks for that one. Okay. Just a small, small information for the joiners, for the participants. Okay. Can I? Saravanan, can I?
Yeah, Murli, please go ahead.
I just want to give a small information to the participant. Can I do that?
Yeah, Murli, please go ahead.
Yeah, thank you. Guys, thanks for your participation. And actually, this is an ad hoc thing that we have just wanted to keep you informed. Like more number of participants are very eagerly watching, and I'm also getting some good feedback. Okay, so that's the reason I just wanted you guys to provide your details for example, name and your mobile number and your, the courses you are looking for, or you're looking for your friend or something, because we are planning to provide free goodies for 2 to 3 persons, okay, who are located in Chennai. We cannot able to send it through the courier, but who are available here in locally, you can come and collect, okay. So for that reason, I just wanted to collect the details from you, like that information, right? The details that where you want to actually provide the details that will be provided by Sarika now on the chat box. So my request to you guys to please, yes, now you can able to see that, right? So may I request you to just click that link and provide your details, and you can just wait for the confirmation. Probably you will be getting the information in case if you are selected, because it is kind of a lucky draw only. Out of the persons, I can able to see 27 participants available. Out of that, we will select 2 persons or to the max of 3 persons, and we will provide them. Okay. Thanks for that. Thanks, Arunan. You can proceed.
Yeah, thanks, Murli. So that's an interesting deal to get a goodie. So students, don't wait. You can go and provide your detail and grab this opportunity. Yeah, having said that, yeah, so I was asking you to also type CC in the chat if it's clear to you. Otherwise, please jot down your questions. Definitely, I'll take it at the end of the session. Okay. Okay. One second. Can you able to follow me? Was it clear? Whatever I explained about the process management. I mean, whoever understood, yeah, okay. Yeah, thanks for acknowledging. Yeah. Yeah, so as I said before, please be more interactive. Yeah, feel free to ask questions, and yeah, please be more interactive. Yeah, this will definitely encourage me. Yeah, thank you so much. Yeah, let's move on. Yeah, what is next is, okay, now we know how a basic read operation is happening in the Linux machine. Okay, now we need to understand when a performance bottleneck can happen, right? So we know all this is happening in a Linux box. Yes, good. So what are the possibilities, or when a performance bottleneck can happen, right? So there are many reasons. One could be like, so this process table, right? So this is a process table. Imagine like you are having a lot of critical application running your machines, and all the applications are keep on adding more number of process into the process table, and each process is waiting for CPU cycles. Okay. So, and then what will happen? Your process table is getting big, and all the process are waiting for CPU. And then if CPU clock tick is not available for each process, then all this process have to wait, right? Thereby, this application can impacted with a performance problem. So if you have a less CPU, or CPU couldn't manage the number of process IDs, there is a chance of getting into a performance bottleneck. Okay, and when the user or an application trying to read a big file from the disk, okay, or imagine like there is a big SQL query is initiated by a user. Okay, an application user is trying to read a big SQL file. Okay, so when you read a file, as we saw in the example, so all this file has to be paged into the memory, right? For anybody to see in their screen, all the files has to be paged into the memory. So if a huge read operation happens, then what will happen? It also requires a CPU clock tick, and there will be a lot of read IO will happen. IO request will be happening to the disk, and not only the disk, from the disk to the memory. Again, there will be another IO. A lot of IO from and to's will happen, right? And your memories also will get filled. Your memories also will get filled with this huge reads. So your memory, if it couldn't able to page big files or a huge volume of files, then you may face performance bottleneck. Okay. Similarly, all this read write are happening in your disk, right? So disk what it will be in the disk, you will be having probably a file system, correct? So this file system, how you are creating? You are creating in a one single disk, or you are spanning into a multiple disk, and how your disk is going to read. So all those things are also matters when it comes to performance. So you can also face performance due to improper disk storage settings also. Okay, so there are multiple ways, right? So another one could be a network. Imagine like you are running a web server, okay, kind of any Flipkart or a kind of a kind of a web server, right? Where a lot of users are coming and hitting this web server. And what will happen? All the users will be reaching the web server through the network socket, right? If the network socket is not tuned properly, then again you will be resulting in a performance bottleneck. So that's why I've mentioned in this slide. So these are all the few areas where you can expect a performance lag due to CPU, due to memory, due to disk storage, due to network, and due to application process. Also, you may end up in a performance issue. Okay, so I mean, it's not necessary to end up with a. It's not necessary that definitely you will end up in a performance issue. It is why because if somebody is not speaking, hello?
I think someone please mute it. Thanks, Arnav. Please go ahead.
Okay, yeah. People, please, who are all not speaking, please be on mute. Okay, so it doesn't mean that everybody have to go out to the, I mean, will be end up in the performance issue. So by default, the system will be coming with the default tunables, right? Default tunables. Why? Because the system manufacturer will not know what application you are going to run, right? So anyway, most of the times this is application or a solution architect job to find the ideal server for certain application, correct? But that happens at the time of purchase itself. Okay, an application owner or application architect knows well about his application, so he will find a identical server for him. But later, when there is a shared application introduced into the same server, so it is us or a server administrator who will have to analyze and tune the system accordingly. Okay, so so that is what about the performance. So we know when the performance issue can occur. Okay, that's also we saw. So see, in this example, we just saw how one single file is read, and we could see a lot of different components are involved, right? So similarly, imagine like if you have SAN storage, there will be a storage network, and there will be a different kind of LUNs and storage also involved. So there will be a lot of IO requests will be happening, right? So there are many possibilities within a system. If it is not tuned, can be end up in a performance issue. Okay, so hope you are clear till here. So now what we are going to do is we are going to learn about some performance monitoring commands. Okay, we are going to learn about some performance monitoring command. So first to come as top command. Okay, so let's see with some scenario. Okay, rather than seeing the command directly, let's see with some scenario so that you can easily catch up. So the stop stands for table of process. Okay, so it's going to display the real-time processor and kernel activity. So what is processor and kernel? So this kernel and this processor, what it does, it can be monitored using top command. So that's what we're going to see. So what I'm going to do is I just clearing the screen, and for better understanding, I'm going to copy it back. Yeah. Okay, so I also have a terminal here. Let me know if the font size is small. See, I'm going to run this command, top command. Okay, so the scenario here is a user is complaining that his application is slow. Okay, he is feeling some application slowness. Okay, I logged into that particular server. I got a shell, and what I'm going to do is I'm going to run the top command. Okay, so this top command is a real-time command, right? So in the page we saw, it's a real-time command. So what is the real time is, see, it's getting updated in every seconds, right? Every seconds you can see the is getting updated. What it means is it's monitoring your CPU and memory in a real time. Okay, yeah. So what is to look into this top output is, so once you log into the application, what you'll be doing is you will be asking the application owner, right, what application you are running. Say for example, he is saying that I'm running some HTTP application or a web server. So you will look for that particular process. You look for that particular process. So this PS command will give you the PID. Okay, this is the PID. What is the PID? We already know. We already learned what is PID, right? So this PID we can get using PS command. Okay. Now we want to know how the kernel is handling this PID. Okay, whether it is getting me the CPU clock cycle or not. Okay, why my application is slow. Okay, I want to investigate that. For that, I have ran this top command in my Linux machine. Okay, yeah. So now I can see lot of different process running. See PIDs, lot of different processes are running here, and I need to look for my process because I know using PS-EAF, I know my process ID, or I also have another column here through which user it is running. Say for example, in our example, if my application is an HTTP, I could see something related to HTTP in this user column. Okay, so now I can also see what is the CPU and memory utilization is taken by that particular process. Okay, so if suppose that particular process is eating or getting good CPU amount, okay, then it is well and good. Okay, if suppose this process is getting the clock cycle, it is well and good. Okay, sometimes it may not get the proper clock tick. Okay, it may not get the proper clock tick. Why? Because there is something called I mean, if you have only one core like this, as I said, when you have more number of process in your process table, each process has to wait. Right? So what will happen? See, when this process is getting executed, the other process will have to wait. So that's why in the recent architecture, you can see even within a one physical CPU, you can see lot of cores, up to 16 cores, maybe you can see. Okay. Give me a minute. Sorry for the disturbance. I got a call. Okay. So coming back here. So yeah, in the recent architecture, we have in one physical CPU, we can see a lot of different cores. So cores is nothing but you will have more CPU clock ticks. Okay, if I say 4 core, then I will have at least 4 different execution or a runtime like this. Okay, so now what will happen? Each process can be using different cycles. Okay, so this is called hyper threading or a multi-threading. Okay, this is called multi-threading because multiple threads are handled by CPU. This is called multi-threading. If suppose your application is not running on all the threads, okay, if suppose your application is not running on all the thread and it is running on only one thread, then this particular application is a single threaded application. Okay, then it is no point even if you have more number of CPU cores, or even if you are going to have another CPU in your architecture, it is not going to help. Then you need to ask the application developer to convert this application as a multi-threaded application. Okay, so that's how you can see whether a single core application or a multi-core application. So how to see this core utilization in top command is, after executing this top command, you have to just click numerical 1. Okay, if you click numerical 1, see, as I highlighted here, you can see the different cores. So in my machine, there is 4 different cores, and I can see their performance, right? What is the user process running in the CPU? What is the system process running? And all these are in percentage. Okay, so I have also given that in my PPT. So if you give 1, you can see the CPU cores. Okay, so this is one scenario where you need to identify whether your application is a single threaded or multi-threaded. In the next scenario, so now all the cores are accessed. Okay, now imagine that all the cores are accessed, and but still your HTTP or your application is still not performing well. Okay, but all the cores are accessed. Then what could be the reason is there could be other process, other unnecessary process that may be eating your CPU, correct? Because kernel will not know the priority, right? It will not know this is the critical application, this is non-critical application. It will just look for the process priority and it will get the CPU cycles. So if suppose you want to, as a system administrator, if you want to instruct kernel that this is my critical application, then it is also possible using nice and renice. Okay, using nice and renice. Okay, so there is a command called nice and renice. So that is nothing but, so this is the priority. Okay, every process will have a default priority which ranges between -20 to, okay, so -20 to 19. So this is by default, kernel will assign the process priority when the process is created. Okay, so what we can do is we can tune this process priority, okay, using nice command and renice command. Okay, so what is the difference between nice and renice is nice command will work when you when you start the process. Okay, maybe I can give a good example. Okay, what I'll do is I can show you a demo itself, which will give you a good understanding about this nice and see, this is nice and this is priority. So based on this priority only, kernel will fetch the CPU clock tick for this particular process. Okay, now I want to reduce this priority. Okay, now I want to reduce this priority. So how I can do is at the time of application initiation or at the time of process creation itself, I can tune the priority. Okay, how I can do is, say for example, I'll create a small script, okay, test.sh or something, and I'm going to give, so just for a demo purpose. Okay, imagine that this is my application. Okay, if I want to give more priority, okay, if I want to give more priority than the default, then I can use nice command and I can give something like this 10, and I can execute that script. Okay, 755. So this is usually after shell script is created, we need to give this. So now I am, okay, so you should be a root user.
Samna, just try with -10.
Sorry. Yeah, no, command is not a problem. I need to switch as a root actually. Sorry. Okay. Okay. Yeah. Oh, thanks, Molly. Sorry. So it should be -10. So what happens is I've initiated this process with a nice value of 10 or -10. So I need another window. Just opening another window. Python test.sh. So we know what is ps command. So now I got the PID. Okay. So now using top command, I can also use this. I can use -p option to see the process ID. See now what happens. Usually the process was having 20 as priority, right? So since I gave 10, it is added. It is added to the priority. So now the priority is 30. Okay. So to understand the priority better, okay, what happens is, one second. Okay. So what happens is the lesser the priority, the faster your process gets executed. Okay, if the process priority is -20 or -90, the more CPU you will get. If you increase the priority, then you will get the least priority from the CPU. Okay, so that's how the priority works. So what we did is we have set this priority so that this process will get the least priority, okay, or the very least CPUs. Okay, so instead we have to give nice value with -10. But when you want to reduce, it requires a root permission. Okay, which requires a root permission. Murali, what is the root password here? Can you send me in?
I'll send you in chat.
Yeah. Sorry for that. Maybe you can send in. And maybe you can WhatsApp me.
They are doing that.
Where, Murali? This chat. Okay, thank you. Okay, so yeah, so now what I'm going to do is I'm going to fire the same command. Now I'm going to reduce the priority. Okay, so since I switched as root, now I don't have that file here. That's why it's throwing error. Not a problem. I can quickly create it. Okay, so I'll execute the same command now. Okay, and I'll look for the process ID. So this time it's 3812. See, now the priority is reduced to 10, correct? So usually the priority, or by default, the priority will be 20 or something, right? It will range between 19 to 20. So this is the value which is considered by the kernel. Okay, so this kernel will always look for the priority, and based on the priority only, this CPU clock tick will be assigned. Okay, so when you reduce the priority, now this application process will get more priority. The now kernel will always look for this CPU, this application. Whenever this application process is coming to this ready state, it will get more priority. It will be assigned to any of the available clock tick immediately. Thereby, you can fix this application issue. So this is the another scenario where you can fix the CPU related issue. Okay, hope this is clear. The second scenario, and the another scenario could be like another user. Say for example, he is complaining that his application is getting hung completely. Okay, his application is whenever they start the application, it is getting hung and it's getting restarted or something. Some kind of issue is happening. Very frequent restart of application or getting into the hung mode. The application is not responding at all. So this kind of issue can happen. 1 second, let me admit people who are waiting. Yes, yeah. So what could be the reason for that kind of hanging issue? Okay, so let me go here. Okay, so in this scenario, an application is running, but this application is getting hanged very frequently. Okay, so this could be due to zombie process. So do you remember zombie process we saw, right? So and any application when it is built, right, it will have a start and stop command. Basically, if you see your front-end application, let it be HTTPD or Apache or Tomcat, whatever application, there will be a start and stop command, right? If the application stop command is not properly written by the developers, okay, what it means is I'm using the proper stop command of this application, but this application is not stopping my child process, but it's stopping only the parent process. Okay, I repeat, my application have the start stop command. I'm stopping the application gracefully, but still the application is not handling the child process properly. It leaving the child process and it is stopping only the parent process. Then this child process, what will happen? They will be left orphan process. Okay, these all process will be owned by init. If you see the PPID, from this PPID process ID, sorry, parent process ID, the parent process ID will be changed to 1. Okay, which is system init, right? Init will take over this child process. Okay, if suppose these are not harm, okay, very few processes are left orphan, and if they're not causing any harm, well and good. On the next restart, this will be cleared. But some application, what will happen, right? This child process will get span or spin, right? It will be keep on creating lot of process IDs. It will be keep on creating lots of process IDs, and each process will try to get CPU and a memory. And what will happen at one stage? Huge number of zombie process will be occupying all your memories and CPU, and that's it results the application to hung because there is no CPU or no memory left in your system. All these zombie process will eat your CPU and memory. So that is the problem with zombie process. Okay, so how to see this zombie process? See this zombie process, right? So when you do this kill -9 command, or if your application is not handling the child process properly, then you will end up with this zombie kind of process. Okay, and this stop command also help you to find those kind of zombie process. Okay, when I run the stop command. Okay.
Sarana?
Yes, Murli.
Yeah, fine. That you are explaining zombie. That there is a question from the one among the participants, Ayyappan. So he asking about just to explain the zombie. That is what you are doing. Just I am keeping you for.
Yeah. Okay. I think I explained now, right? One more time to explain. Okay, one more time to explain. Okay.
No, he asked earlier, but now I think we could.
Yeah, not a problem. I'm happy to do that. Okay. So zombie is one of the process state when the child process are not handled properly, right? So say for example, when I type this command, right? PS command. Okay, so there is no test process. Yeah, I'll show you what is parent process and what is child process. Okay, I have to run this. So when I say, for example, this is my application. Okay, this is my application. Then, so this application have only, one process ID, and there is a PPID. See, this is the PPID, correct? This is the PPID. If suppose I have lot of child process, okay, in this example, in this first example, if you remember, we are reading a file. This is the PID, and in turn, this is invoking other read IO. So those are all child process. So now this process will be PPID of this child process, right? This will be the parent process of this child process. If suppose I am killing this process without closing this subsequent process, what will happen? All this process will be left orphan. Orphan is kind of there is no parent at all, right? So it's kind of family. Okay, that should be a parent to handle the child. If parent is dead or killed, child will be left orphan, right? Same process, same thing is applies to this computer also. If the parent is not there, the child process, nobody know how to handle, right? Linux will not know how to handle this child process. Why they are there in the system, what they are doing, nobody knows. Okay, so the init process will take ownership. But the init process is the root what do you say? It is a root equivalent one, right? So it can do anything, but it will try to take the ownership of this orphan process. But problem is the application developers who wrote this code, right? If they're not written it properly, okay, this will be keep on spinning. This will be keep on spinning in the sense you will see PID 0, PID 1, PID 2, PID 3. So lot of process will be bumping up your process table, and each process will be trying to access your CPU and memory, right? So finally, this will be end up in the situation where you will not have any pending CPU or memory left for the next process to handle. So this is called a memory leakage. Okay, this is also called as memory leakage. Okay, if this application is not handling their child process properly, that will lead to memory leakage. Okay, so when your memory leak is happening, a lot of PIDs are getting spinning, and these process IDs, these spinning process IDs are called zombie process. These are called zombie process. Why? Because they are not there for any purpose. Okay, their parent is already killed. They are there for no purpose, but they are using the CPU and other resources. So that is called zombie process. Am I clear?
Sarana?
Yeah, yeah.
One question from Uttra Lakshman.
Yeah, I saw that. Yeah. What happens to zombie process when parent process is restarted?
Exactly.
Yeah, good question. So as I said, every process have a unique process, right? Unique process. So first time I start a process, it's a unique process. It has its own child process. It has its own child process. Next time, when you restart the same application, you are not going to get the same process ID, correct? Next time when you are restarting, you will be getting another unique ID. And for that, you'll get another set of child process. This process cannot take ownership of the existing process. This is completely isolated. That is process management. That kernel will allocate a unique process ID, not the existing process ID. So there is no reference at all between the old process and new process. Okay, that's why init is taking control. That's why init is taking control of this orphan process. Does that answer the question? Okay, great. Yeah. Okay. Yeah. Yeah. So I think we have spoken. I mean, we covered good about the. I mean, good scenarios about CPUs, right? So we saw about multi-threading, single-threading application, and we also saw some top CPU consuming process. How to improve the priority using nice and renice command. And again, the difference between nice and renice is whenever you create a new process, you can use nice. For an existing process, if suppose this process is already running, right? If I want to change the schedule, change the priority of this process, then all I have to do is I have to replace this nice command with renice. That is all the only thing I have to change, and I can give this PID. Okay? So that is the renice command. And for CPU, we also saw the zombie process. Zombie process, and this zombie process can be seen here in the top command.
Someone is not speaking. Can you please mute your line? That's a disturbance. Okay, please go ahead, Sarana. Thank you.
Yeah, thank you. Okay, yeah, so I think we are good with this. 1 second. Yeah, let me go on to the next slide. So we spoke about tuning processor, and yeah, so let's look into the CPU or memory now. Okay, let me clear this window. So I love this way of pictorial representation, right? So you can understand more rather than speaking more theoretically. So this helps a lot. So now we have seen various scenarios respective to CPU, right? Single-threaded, multi-threaded, we saw, and like I said, we see multiple scenarios. Now let's see when the memory get bombarded, right? So memory-related issues. If you want to troubleshoot memory-related, then vmstat is the best command. Okay, so vmstat is the best command, and vmstat stands for virtual memory statistics. Okay, so I'm just clearing the screen, and I'm going to run vmstat command. Okay, it follows with a couple of entry. So I'll tell you what it is also. So this 2 is the seconds. So every 2 seconds, give me 5 output. Okay, every 2 seconds interval, give me 5 output. So this is a kind of real time, but it's not going to occupy the entire. It's not going to be top on your memory usage like the top command does. Okay, this will just give you the output. And again, here, what are the important things to see is free memory, right? What is the amount of free memory? Okay, so now let's come back to come for a scenario, right? Let's take a scenario to understand. So a user is complaining that a SQL query is taking long time. Okay, so now here a user is trying to do a SQL query, and it's taking very long time. Okay, so you are logging into the system, and you are seeing the read operation is very slow. You are trying to read a file, and that operation is also very slow. And so what you have to do is, now we need to check what is the available memory, what is the free memory, because we know any read operation is trying to get the file into the memory, and thereby we are seeing it in our monitor, correct? That is the working operation we know. So now, in order to pop up this files as a page, you need to have the enough memory. You need to have enough memory. If you don't have enough memory, then obviously we will be end up in the performance issue. So now, as a system admin, I want to see the free memory available in my system. For that, I can fire this vmstat command and see this free section. Okay, I could able to see free memory, but sometimes this free memory also mislead. Okay, I'll tell you why. Okay, so you found that you also found that a lot of read-write operation is happening, and the memory is busy in writing or reading more files. Okay, so you are noticing that. Why I said this memory or a free memory will be misleading is, okay, how the memory will work, right? So when any file is read, okay, read or write, say for example, in this scenario, we read this file, right? Cat file. So after reading and this process is completed also, though this process is completed, the file which read from the storage will be remaining in the memory, It is not like after the process is completed, your files will be deleted from the memory. Okay, it will be retained in the memory. Why? Because whenever you are reading the next time, this read will be from your memory itself. Okay, instead of searching again in the disk, this search will be in the memory itself. So it will use a algorithm called LRU. LRU stands for least recently used. Okay, say for example, first time when I access this file, it will search in the storage and it is placed in the memory. Next time when I access, it will be from the memory itself. But the user is not accessing this file for long time. Okay, 1 day, 2 day, 3 day. After 5 days, this least recently used, right? It will check. Okay, this file is not used for recently for some time. Then I can delete this. Okay, that is called the least recently used algorithm. This is an aging algorithm. Okay, based on this aging algorithm, these files will be removed or kept from the memory. Otherwise, all your files will be kept in your memory itself. Okay. May I request you to go on.
Those who are not speaking, can you please keep it in mute? Sorry, Sarana. Someone is good.
Yeah, thanks for that. Yeah. Okay, yeah, thank you. Yeah, so that's why I said the free memory could be misleading. Why? Because that's how the Linux works, right? So whenever you read file or write file, those files will be taken into the memory and they will not be cleaned immediately. They will be cleaned only using the LRU algorithm, and this LRU algorithm stands for least recently used algorithm, and it's an aging technique, and this will clean only the file which is not used recently. Okay, so that's how the memory is working. So here, how to mitigate the problem? So the problem is slowness of reading a file, and we could see there is a lot of read IO is happening, or we could be able to see there is a very less free memory. Why? Because there is a lot of read and write happening. There is a huge SQL query is running. Okay, here as an interim solution, actually the permanent solution is to add more memory, which involves a lot of cost, right? So if you want to add more value to the business, and as a quick time solution, what I can do is I can bring a technology called swapping. Build a technology called swapping. What is swapping is? Instead of buying a new memory and place it in the hardware, I can ask or I can say a portion of the storage to act as a real memory, but actually it is a virtual memory. Okay, so a portion of the hard disk will be acting as the memory. So this portion is called as the swap space. This is going to act as a memory for me. So without purchasing a real memory, you are fooling the application, or you are saying that application that use this portion of hard disk as a memory, so that now you have more memory spaces to handle the large pages. Okay, and that's how you can rectify this problem. You can see here tremendous improvement in the performance when you add more swap spaces. Okay. So when you add more swap spaces, there is a command readily available in it to create how to create swap, how to swap on and all. So you can go through that. So imagine that you have created a swap space now. Okay, you have created the swap space now. So now what will happen is, as usual, the files will be paged into the memory, and now this LRU is looking for the least used page, and this least used pages are moved to the paging. Okay, paging, because this is also a kind of memory now. Okay, so this activity is called as paging or swapping. This activity is called as paging or swapping. Okay, so this is very important in Linux. So there is again a do's and don'ts in this paging also. Okay, just like that, I cannot keep on create more paging. Okay, because I have since I have lot of disk space, I cannot go and create swap 1, swap 2, swap 3 and all. Okay, there is a best practices. Okay, it is limited to only one. Okay, it's always recommended to have only one paging. Okay, maybe later if you feel if you want more paging, you can increase the size rather than adding more count. Okay, so those are all do's and don'ts when it comes to paging. Okay, and what is what we need to do in the vmstat command, right? We were learning about vmstat. So free we already saw. So this SI and SO column stands for swap in and swap out. Swap in and swap out. Okay. So what we were seeing here is whenever okay, sorry. So what I'm supposed to say is, yeah. So I said this is swapping, right? So what is swap in and swap out? There is two columns in the vmstat command. It says under the swap section, it has SI and SO. Okay. So in this swapping, there is two things this different, right? So SI stands for every second from disk. Okay, from the disk, if any file is moved to the memory, it is SI. And every second, the packets which is moved from memory to this storage is called swap out. Okay, so
guys, can you please 1 second, please, guys, can you please mute it if you're not actually speaking, so I can be able to see. Sundar, can you please mute your line?
Yeah, much better. Yeah. So, yeah, thank you. Thanks, Murli.
There is one more Sai Rock in the name. So can I request Sai, can you please mute your line, because that's not affecting others. Sai, thank you.
Yeah.
But still I can able to see that. Someone joined Sai Rock. Okay. Fine. Please proceed.
Yeah, thanks, Murli. Yeah, so I quickly summarize. So a user complaining there is a slowness in the file reading or a writing operation. You logging and you are seeing that your memory is bombarded. There is very less free memory, and you are using vmstat command for that. And to fix that, what you're doing is you are creating a swap space in the storage. So it's going to act as a real memory. It's not a real memory, it's a virtual memory. But for application perspective, it is going to be as a real memory. So application will perform well, actually, comparing to the previous state, right? So you are adding a swap space, and you want to check whether your swapping is working or not. For that, even for that, you can use this same vmstat command. You have to look for SI and SO. So SI and SO stands for swap in and swap out. So when any read happens from this disk to the memory, it is called swap in, and from the memory to the disk happens, it is S out. Okay, so this is SO, this is SA. So that's, you can see in the vmstat command, and you can ensure that whatever swap you created is working or not. Okay, and the other thing, this is block in and block out, which is related to block files. And these are all CPU section. We already know, right? CPU section. What is the percentage of user process happening here? What is the percentage of system process utilization? What is the ideal and what is the weight? So usually we will see ideal, right? If your CPU is ideal for more than 90, then it is good sign. See, here we are seeing CPU is ideal for more than 90. which means you have enough CPU to handle the jobs. Here, similarly, if you see free is more than 50 or 40, it is a good sign. Okay. Similarly, this VMstat also used to know when your this paging is getting bombarded. Okay. If you see more number of swap in and swap out is happening very frequently. If you see swap on swap out is happening here, large swap in and swap out, which means that your paging space is also utilized very heavily. Then you can consider increasing the paging space size. Okay, swap space size or something like that. Okay, that is also possible to fix the issue. Okay, so this is comes to the this is on the memory end, memory side. Now let's quickly see one for the storage, and then we'll move on to the process management tool. I'll quickly, instead of going to the paint, I'll show you here. So when it comes to performance management on the monitor, on the disk, we can use iostat command. So if you notice, any command that's that end with the stat is for the performance manager, right? So you have vmstat, iostat. Similarly, you have netstat. A lot of commands which ends with the stat will be for the performance monitoring. Okay, so this iostat will help you to monitor the input and output devices, right? Like your disk and what is the average transfer rates? Okay, average transfer rates happening between the memory and the disk. So those kind of information can be seen from this iostat command. Okay, when you fire this iostat command, you'll see a similar output where you can see the BLK read, right? So this says what is the number of block per second from the disk. What is the amount of read is happening? What is the amount of write is happening? Okay, this happens. This is shown in the blocks. Okay, this is shown in the blocks. If suppose you don't want in block, if you want in megabytes, okay, these are all in KB. If you want to see in a megabyte, you can use M. Okay, let me show you this command. See, I can run this iostat command as similar to vmstat command. Okay, good. So this all comes under the systat package. If you don't have this package, it will not work. Okay, good. You learned this systat as well. Okay, okay, but it's not installed for some reason. Okay, good. See, so now I have this disks SDA0 and SR0, or these are all different devices, and these are all different metrics. Okay, this is related to CPU. Okay, I can ignore this because we know what is under CPU. So I'm just ignoring this. And when it comes to here, these are all the kilobytes. These are all kilobytes, or these are all the IO requests, the transfer which is happening between the disk and your RAM in the blocks. Okay, suppose, as I said, if you are not comfortable with the kilobyte, then I can use iostat, I can D for device, and I can use M. Okay, M will give me in the MB. See, now it is in megabyte. So some will be good with the MB, right? In the calculation will be easy in the megabytes. So if you want in MB, you can use the M attribute. Okay, so this is something which is good to understand how your disk is operating. See, in this example, if you see this one disk is utilized, but other disk is not utilized at all, which means the file system is residing in this disk. Okay, likewise, you can easily understand. Okay, okay, so what could be the problem? As I said before, the file system is created, you have more LANs, but file system is residing in only one system. So this application is trying to write in only one file system, okay, or only one disk. They are trying to use only one disk, but it is not properly spanned to the other disks. That is why this particular disk is overutilized. That's why it is related, it is ended up in the performance problem. So what solution you can give is, you can span the file system to the multiple LANs or multiple physical volumes. Okay, you can span it so that this disk read IO will be spanned to the multiple reader or multiple heads actually. So which will reduce the overloading of this particular resource utilization. So that's how you can analyze and fix the storage related issue. Okay, so now we have seen many scenarios for CPUs, if there is a performance bottleneck, how to identify the performance bottleneck and what to do. Okay, and how to identify the memory bottleneck and what to do if there is a performance bottleneck, and how to identify a disk related issue and how to provide a solution. We have seen some decent scenarios, right? There could be a lot of other scenarios. Okay, there could be a lot of other scenarios, depends on your application mainly. Why? Because application is the major driver who is going to use the infrastructure. So this kind of scenarios will vary from one application to another application. Okay, now we are going to move from the performance monitoring tool to performance monitoring commands to performance monitoring tools. Okay, so what is difference between monitoring commands and monitoring tools? So these are all some commands which can be used when the real-time outage happens. Okay, so usually what will happen in IT, right? An application team will be raising an incident. They will say that my application is slow. They will raise an incident in their some ticketing tool. You will get the incident, and when you log into the system, you may not find the problem at all. Correct? Sometimes it happens, right? The user will be reporting an issue, but when you log in and see, you may not see that issue at all. Why? Because it could be a spike. Okay, that issue might have happened at a specific time. Okay, specific time when many users are logging in, or when other application is starting. So that could be many reasons, right? So an application problem or a performance problem can be a spike or a hike. So those kind of spike and hike happens at some kind of time, which may have pattern, which may not have pattern also. Sometimes I can say that this problem arises between 10 to 11. Sometimes I will not have clue at all. It happens, it goes, it happens, it goes. So those kind of issues can also come, right? So without any clue. So those kind of issues need a historical data to analyze. Okay, those kind of issues need a historical data to analyze. For that, I need a performance monitoring tools. So these monitoring tools not only help to record the historical data, but they also help in providing a dashboard kind of thing. A decent visualization is given using a chart. How your CPU is utilization, how utilized, how your memory is utilized. At the time of CPU, at this time, what is your CPU utilization? What is the disk utilization? So you can correlate. My memory is least utilized but at the same time, my CPU is overutilized. So based on that kind of dashboard and the visualization charts, we can take a better decision. And you can also convince your management. You can convince your capacity team using the evidence. Okay, you can use it as an evidence that this particular application, you can also use it to defend your or what do you say? You can convince your application team, right? Saying that, see, your application PID is utilizing this particular CPU or memory at this time. So you have a perfect artifact with you to argue, right? So those kind of information or thing is available, readily available only when you go for monitoring tools. Okay, and of course, benchmark. As I said in the beginning, right? We were seeing different bikes and all, right? So how we know when it comes to server, how a server will act like a moped or is a super bike? How I know how my application will work? So at the time of system build itself, okay, it is recommended to do a kind of stress testing. I don't know how many of you would have heard this. Okay, there is something called stress testing. Okay, so I am building a machine. Okay, I'm commissioning this new server. Okay, this could be a entry level, this could be a mid level or a mid range or a high level, whatever this server. I am deploying my application. Okay, and I will do a stress test. Stress test is nothing but I will just simply do a load test. Okay, I'll say that currently my CPU utilization is 25%. Okay, I'll simulate. I'll do a simulation. I'll simulate the load. I'll say that at CPU at 25% utilized, what is my performance? What is my application performance? When my CPU and memory utilization is 50%, what is my application performance? When it is going beyond 90%, what is my application performance? So when I record this performance, so this is called baseline. We'll call it as a baseline performance. Okay. When you record this only, we will know that this particular server, this particular hardware configuration can produce this result. Okay, if anybody or if an application team expects beyond this expectation, which is not possible, we can simply say that this server with this configuration can only perform up to this baseline level. If you expect beyond this, it is not possible. Better go for an hardware upgrade. Okay, so for that we have to do this stress testing at the time of system build, which will give you the baseline performance. We can capture this baseline performance, and later when you have this performance tools, then we can correlate. Because this performance tool will help in the real time. This is you are simulating in the stress, but in the performance tool, it's a real time. In the real time, it will show you that CPU utilization is something like this, and you can see here, yes, when we tested at 50%, the baseline was this. In real time, at 50%, the baseline is this. So this hardware is working decently or as expected. So we cannot go beyond this. We cannot tune beyond this. Maybe we can go for the hardware upgrade or adding more CPUs or more memory. So those kind of management decisions is possible only when you have this kind of historical data using performance monitoring tool. Okay, so these are all some reasons. There could be other reasons like spikes and hikes I already I already discussed, and corrective actions, benchline. See, last minute outages. As I said, zombie process, right? The zombie process and all, immediately it will not create an impact. Zombie process we saw, right? Slowly it will create a process. Okay, the application will be running. Somebody will be try to stop the application. The child process will left orphan. It will slowly create a lot of process, and each process will be eating CPU and memory. And finally, if you see, the application will go not reachable, right? So this kind of issues, if you have a performance monitoring tool and somebody is monitoring it, you can see that slowly your CPU utilization will be going up in an upward trend, or your memory will be going in an upward trend. Then you can immediately log in and see, oh, there is a zombie process which is doing all these things. I should do something. Okay, if possible, you can do something without a restart, which is well and good. You can save a outage. Not only in zombie issue, any other related performance issue, you can use this kind of performance monitoring tool to avoid the outages. Okay, so there are many other advantages also, which I may not listed here. Let me quickly see the chat window. Okay, I'll take this question last on the zombie process. Yeah. Okay, good. So that is the use of performance monitoring tool. So now we know what is performance issue, what is performance bottleneck, how to identify, how to provide solution, and what is performance monitoring tool, and how this performance monitoring tool can help in taking a lot of decisions, right? Lot of decisions. And yeah, and I have also given a few performance monitoring tools, right? Which I work. There are plenty in the market. Maybe you can also comment if you have come across any performance monitoring tool. So I've just given few to name. There are many open source and many proprietary oriented also. So these are all some of the performance monitoring tool available in the market. Okay. Okay. Now we are good. So now the thing is on the bottom line, what I'm coming to say is, if you are going to do any performance tuning, it is must to have, or it is good to have a decent understanding on your hardware, on your application, on the operating system. So that's what we saw, right? So initially we saw RISC architecture, blah, blah, blah. And then we saw process, how the process is working. And then we saw how the each CPU, each memory is how it is working. And then we saw the commands, and then we came to performance monitoring tool. And then we also saw the application, right? So there is the application is a key player, because the developer decides how the system calls has to happen. So all this knowledge is essential, right? So it's not an easy task, and it's not a thumb rule. Like I did this and it's working today. It will work for the as same as in this other system. It's not thumb rule at all, right? So so having said that, what I'm coming to say is, when it's coming to performance, I always recommend to get a expert opinion also. So how to get an expert opinion? If you have a Red Hat subscription, then you can raise the incident to Red Hat, and you can provide the source report. Okay, most of you might have already done. So this command is from the net only. So using this command, you can provide this source report from the performance bottleneck system. This will take in turn take a lot of performance monitoring commands like top, SAR. So a lot of reports will be taken and sent to the Red Hat team. So they may help you with the performance tuning also. Okay, so based on your subscription again. So that is star over there. So that is how to get help. And how to get help on the performance monitoring tool, that we know, right? Man command. Of course, you can use man command, and there is a lot of other commands to explore also, because considering the time, we are restricted with a few commands. So as I said, there is if you want to explore something on network, you can go for netstat command, iostat, pstat. There is plenty of command. Okay, you can just Google and you can see there is plenty of command, and you can also explore what is there in the /proc. Okay, so /proc, there is a lot of files which will have the tunables. You can use systemctl command to tune the parameters. Okay, so there is lot, and I know you understand, right? Within 40 minutes, I cannot convey all the. I cannot make you all as a performance expert. So I could cover all these things. Maybe in the next session, somewhere in the next workshop, we can see the tunables if time permits. So having said that, let's move on to the best practices. So as I said, there is no thumb rule or a fixed solution, one-stop solution. Yeah, I did this. It worked for this machine. I'm going to do this for all the machine. It will not work. Okay, you have to be very extra cautious and ensure that your operating system and applications are up to date with patches. Okay, most probably this patching also, if you're not doing properly, if you're not up to date, that will also end up with the performance problem. And ensure you take the configuration files and data backup before you tune any machines. Okay, if you're decided to tune any machine, first I'll encourage you to go with the lower environment, right? Test machine or something, test it and monitor it. Okay, using the performance monitoring tool, monitor it for at least 3 or 4 days, and ensure the shared application are also not impacted. Why? Because you may be tuning your system for X application, and you may not know that Y application may be impacted because of that. Okay, so monitor your system, get the feedback from your users, and then you go for production deployment. Okay, and similarly ensure you have all the backups ready. Okay, if suppose your system is malfunctioning, your system is not coming up properly after the performance tuning, you should be ready to recover it also, right? So ensure that you have the proper backups. And as I said, stress testing, do stress testing, record the baseline performance, because if you do not have the baseline performance, you cannot compare, right? You cannot compare with the performance tools. So that is the reason why I am encouraging you to take a baseline performance, and only do this tuning when you encounter a performance bottleneck. Okay, what I mean is, if a system is running properly, okay, there is no complaint raised by the user at all, but you think okay, if I could tune this machine, it will be good. Okay, unnecessarily don't go and touch the machine if it is already running good. Okay, that is one another advice from me. Yeah, so there are other basic commands like SAR, LSOF to see the open files, TCP dump. If you suspect your packets, it's like HTTP, FTP, if you want to trace them, you can go for TCP dump, netstat, IOTop. So do explore these commands, understand how it works, use man command, use Google to understand. Okay, so this is a very interesting area. Performance tuning is really an interesting area. It is time consuming, but it is, trust me, it is really a very, very interesting area. Yeah, so having said that, I'm done with the workshop, and I'm going to run through the courses offered here. And after this, I'll take the Q&A. Okay, this should not take much time. So these are all the courses which we are offering in OSC Labs. So we cover Red Hat Linux and Python, Ansible, and we cover Red Hat OpenShift. We do cover Kubernetes and AWS Cloud, Azure, IoT. So all these, what do you say? All these emerging technologies, which can be a shield for your upcoming job or career move, or even a horizontal upgrade in your current position. So all these courses will help you. So I do recommend you to pick a path and keep yourself updated. for keep yourself ready for the upcoming workforces, right? And so this is the offer of the day. So if you are going to register for any of these courses by today, so you can avail these two, what do you say? So you will get a free Linux book, which is worth of 3,000 INR, and you also will get a 10% reduction as a discount in your training fees. Okay, so these are all offer of the day. You can avail it by enrolling yourself in any of these courses by today itself. Okay, and these courses are intended for system administrators or anybody who want to become an system administrator or anybody who is looking for a domain change. So you can think about this. You can call me, or you can speak to Murli, or you can speak to any of our staff. They will guide you. Like if you want to have a domain change, they can have a counseling with you. They can understand your need, and based on that, they can show you the right what do you say, right learning path. And so why YSC Labs? Okay, why not any other institute? Why YSC Labs is so we have some features in YSC Labs, right? So when we provide the basic Linux training, so we ensure that we provide you with a hands-on Linux training with enough labs. Okay, and we also cover some basic Python scripting. Okay, we are making you for interview readiness through some mini projects in Linux. Okay, we encourage you to do some projects. We used to give some tasks, which is very appreciated by freshers and domains. Why? Because so that really helps them to crack interviews. Why? Because they can they can answer the interview in a very confident way, right? So that way, these mini projects are very helpful. And we also have some mock interviews, and we make them prepare, and we also guide them. We also provide some opportunities for them to attend interviews. Okay, so these are all some features from YSC Labs. And of course, I must say this: this is not for everybody, but anybody, any students, if you're facing any financial challenge, and if you feel like you couldn't pay the entire fees, maybe you can pay part, or even you can take a full credit and you can pay later, or you can come. Even I mean, we are doing it as a service only for the people who cannot afford for the training fees. Of course, you can come. We are very much here for helping you. You can take the course. You can get a job. We will help you to get a job, and that way we are providing a small services to the society. So if you're interested, so here is the contact number. You can reach us at any of these numbers. You can take a snapshot, and you can reach us. Maybe our staff will be reaching you to know your I mean, to know your readiness. But you can also reach us if you're interested to enroll in any of this chapter courses. Okay, I'm just giving a pass here, and I allow Murli or Sarika to to cover me if I missed here anything about these courses, and then I'll take the Q&A. Murli, do you want to add anything?
Yeah, thanks, Tarunan. Thanks for the wonderful session. It's really a great, and I got very good feedback in parallel. And I just wanted the participants to actually give the details. Okay, probably they might have busy with listening the class. Okay, if you provide that, right, probably today evening we will be collecting the details, and we will announce you, or we will reach out to you over mobile, and you can come and collect the goodies. Okay. So we are planning to provide to the max of 3 participants. So your name will also be there. Okay, so believe that and provide the details, and right. And I think that information, the Google Sheet information, is already shared among that in the chat box. Okay, so and please provide the details and take that. And other than that, if as Tarunan mentioned, if you are interested in the Linux or any other courses which is mentioned over there, right, you can reach us today. And if you are in like a position dilemma that we can take it now or we can take it later, like that, right? So please reach us that, okay, so that you can take an offer also. Okay, if you are coming by tomorrow, okay, after today, any day like tomorrow or Monday, we cannot able to provide, and this is only for the promotional offer that we are providing. And that too only this, because other than Other days, normally we will not, and we will not encourage to give any kind of the discounts. Okay, so that is the reason I'm humbly requesting, guys, you please, for your enrollments or registrations, okay, please reach out any of the numbers which Saravanan provided over there, okay, or else you can Google OIC Labs and you can able to find out the numbers over there, okay. And one more thing, as Saravanan mentioned, we are also offering free trainings for the guys who students that is mainly for Linux only, not for any other courses. And as they, because that is a that's something like the kind of the entry level course, and we will all offer the free training in the sense that depends. Okay, so if the student cannot able to provide any money, like, and they are really very financially challenged, then we will accommodate the student and try to provide the training, and we will also, and not only that, we will also try to place that student ERT, and we will try to provide the opportunity. Only thing is the courses if are in the virtual, and they wanted to have like a laptop or something to attend the class. Okay, and any clarification or doubt, please reach out. That please note that I cannot able to provide for all that, as because I'm also running, and you know that, right? We also wanted to face some other kind of what I can say, like the facility charges, etc. Right? So this is only for us, because this is not for any kind of advertisement or something. So we just wanted to promote, or we just wanted to do something to the society, and because I could able to see a lot of others are actually scattering towards other industries, and really very sad to hear those things, and try to avoid as much as we can. Okay, and if you are good and you are thinking that, okay, we can recommend that particular friend, or your family friends, and or someone, right, who is actually not in a good position to take any course or something, please do them. Okay, that's that you are doing good for the society. Okay, Sarika, Sheikh, you wanted to add something else? Saravanan has completed his part, and anyone wanted from the marketing side, if you wanted to pitch in?
Just the candidates needs to be filled the Google Sheets, sir. That's it.
Yeah, okay, that's fantastic. That's fantastic. Okay, so please, guys, please provide the details in the Google Sheet, and till probably in another 1 hour time, we'll keep open that Google Sheet, and we would request. Okay, don't worry, guys. We will not actually call multiple times to you. At least one time we will call, and that is not a problem. Okay, so sometimes today you may have request, or tomorrow you may have request. Okay, in case if your request you wanted to take that, you can. Otherwise, not required. Okay, thank you. Saravanan, really, I have to be very much thankful for the wonderful session. It's actually, you have worked a lot, and really it helps everyone here. Okay, thanks a lot, Saravanan.
Yeah, thanks. Yeah, let me go to Q&A session. Maybe we can have another 15 minutes for Q&A, and we can only.
Yeah, please. Over to you. You can.
Yeah. So I would like to go with this question. So there was a question, right, on the how to identify, from Krishna, how to identify and kill zombie process. Okay, so how to identify and kill zombie process? Okay, good question. So to answer it directly, it's not possible. Okay, to answer it directly, it's not possible. Why? I tell you. So zombie process is a process. Okay, zombie process is a process. When the application is written, the developer failed to write the stop process properly. Okay, he failed to handle this kind of child process properly. Okay, because he has to say this parent process that whenever you are going to get stopped, it's your responsibility to stop your child process. Correct? So that code is missed by this application developers. Okay, so that is the reason when this parent process is abruptly closed, it is not handling the child process properly. It is leaving it, and init is taking over it. Okay, again, this process, child process ID, will also not have the proper details. What to do if there is no parent process? Should I get closed? No, they don't have any idea at all. And since this was having different PID and init also doesn't know how to handle this, how to close this. Don't know. Only this application team know how to close this PID, right? So init also will not know how to close this. That is the reason we cannot kill this zombie process. Not all the zombie. Very rarely, if suppose application developer have given a proper code, may be possible. But most of the cases, it will not allow us to kill the zombie process. Okay. Only interim solution would be go for a reboot, which will clear everything. And even when you are rebooting, if your application is in the startup, again you will end up in the same problem. So before reboot, if possible, remove those kind of suspecting application from the system startup, go for a reboot, and then use this performance monitoring tool, identify the specific application, ask the developer to fix it, and only then you can get out of this problem completely. Okay, without the application team support, it's not possible to fix it from our own end. Okay, this maybe this cron may help to find the number of zombie process, but it will not help to kill the zombie process. Okay, hope I answered your question. In this case, whatever taken by init is zombie process. Yeah, so not whatever, the child process which is left orphan. The child process which is left orphan. So if you go to system and see in the top command, zombie, right? So here you can see a lot of process, and if you see this process in this process or using PS command, right? If you use PS command and all, in the PPID you can see this kind of one. If you see this kind of one and a lot of application process, so those kind of process can be called as child process. Okay, this way you can find this. Okay, and if you want to know what is my process state, I was explaining 4 different process state, right? If you want to see in the top command, you can see the yes column, right? So this yes is saying that this process is in sleeping state. Likewise, you can easily identify. Okay, yeah. So any other questions? You can also speak up. You can enter your questions in chat. You can also speak up. And if you don't have any questions, but you have anything to share, if you have any feedback on, you might have faced any performance issue before and you might have provided any solution, you can also share with us. Anytime, Krishna. Thanks for asking good questions. Yeah, how to deal performance issue. Yeah, so as I said, so it's a cycle, right? So when you build the box, take the baseline, record the baseline, and then immediately you see whenever you build the box, day one you will not face the issue, right? So slowly when you started using the system, you will go to the optimal level, right? Slowly the system CPU process will creep up to 25, 35, 55. So when it goes beyond 80, maybe you will feel slowness, or application will feel the slowness, because only when you're started using your resource optimally, you will come to know the differences, right? So when they report, you have to see what is the level of utilization happening in your machine. So as I said, go by a cycle. Okay. First understand the problem. Okay. First listen to the application team. What problem is reported? Are they facing problem related to CPU? Because when you understand the problem, you can easily think, okay, so this problem, as I said, if they face the problem in reading a file, okay, this could be related to memory. If they're facing a problem on the slowness, okay, this could be due to CPU. So go with the flow. Okay, check for CPU, check for available CPU, free CPU, check for idle time, check for free memory, check for the disk IO writes happening, check for netstat, check for users. And so likewise, it's a step-by-step process. Okay, as I said, there is no thumb rule. So it depends on the application, depends on the issues. So you have to handle it as a what do you say, sequentially, right? Sequentially, one by one. So when you find a clue, okay, so something will be abnormal, right? So there comes the performance thing. What is that? Tools. So tools will help you with the historical record. You can take and see, okay, yesterday this was not there. This much CPU utilization was not there. Today it's happening. So what is the new process came in? What is the new change that happened? Go to the incident, see if there is any new application is deployed. So that application could have caused it. So that's how you have to do the root cause analysis. Okay, so it's not a thumb rule again, as I said. Okay, it's a sequential process. You have to think logically, as I said. But all this experience, all this comes by experiences. Of course, definitely you can do. It's not a rocket science. Definitely you can do one day, but it comes through the rocket science. You need to spend some time on this. As I said, a lot of performance monitoring tools are there. Understand each and every component. Okay, what this is showing, what this is showing, and so slowly one day you will be an expert on this. So that's how we need to deal with the performance issues. Hope that helps, Arvind. Any other questions?
Saravanan. Yeah, any other questions, guys? Thanks a lot, Saravanan. Arvind, is that okay for you? If your message, that really helps. Saravanan. Okay.
Oh, thank you.
Thank you. Okay, any other questions, guys? I'm really appreciating everyone for your valuable time spent here. That's really great. Okay. So, thanks.
Yeah, thank you all for being my wonderful audience. So if there is no question, there is one question, right? What vulnerable patching? Yeah, so what is vulnerable patching is, okay, if there is any system update, right? In the Linux machine, you used to do, what is that, yum update all, right? So it's basically a complete update. So if there is any security patches is there, you will get an emergency fix. So cumulative of this emergency fixes are released as the patching, right? So it is called as vulnerability patching. As similar to you upgrading your mobile, right? You upgrade your mobile with the latest OS versions. Similarly, you can update your operating system with the latest patches. Sometimes the latest features, whatever introduced from the Linux, may not be there in your system. It can also called as the firmware upgradation or OS upgrade. So you can call it as a VTM patching upgrade. So those are all some terminologies.
Yeah. Thank you. Basically, vulnerability means the weaker portion on the server. Okay, so for that, providing patches.
Yeah, true.
Thanks, Saravanan. Okay. Any other questions, guys? So this is beyond the time limit, whatever. But anyhow, I think this would be helpful for everyone. Okay. If there is no further questions, thanks, Krishna. There is no further questions. We'll wind up, and I would also request everyone that we are posting probably 1 or 2 workshops conducting every month, and I would request your presence and your valuable support. Okay, so that is the only one that is actually keeping us in an energetic mode and very active. Okay, so that's it from this one. Saravanan, anything else, Saravanan?
No, I'm done, Murli. So I'm. Thank you all for being wonderful audience. I'm looking forward to see you in any of the courses. Thank you so much.
Thanks a lot. Thank you. Please fill up the Google Sheet and take the goodies. Thank you. Bye.
Thank you all.